Example problem 1 reads, what is the volume flow rate of Diet Coke traveling at a speed of 1.5 times 10 to the minus 3 meters per second through a straw with an area of 2.56 meters squared? So the problem tells us that we have a velocity of 1.5 times 10 to the minus 3 meters per second. And in this course, anytime you see something listed in units of meters per second, it's usually going to be velocity. The problem also tells us that we have an area, because we've used this before, we know what that means. We have an area of 2.56 meters squared, and it's asking us for the volume flow rate. Now, this is one that we haven't seen before. It's a fancy looking F, and I can't draw it, so I just draw it like that, and that's perfectly fine. It doesn't have to be beautiful or anything. So the formula for volume flow rate is volume flow rate equals area times velocity. And so we know that area is measured in units of meters squared. Velocity is measured in units of meters per second. So when you add those things up, volume flow rate has to be measured in cubic meters per second, because none of this stuff cancels. So we are looking for volume flow rate. Our area is in the correct units. Our velocity is in the correct unit, so we can just go ahead and plug this into the volume flow rate equation. So volume flow rate equals an area of 2.56 meters squared times a velocity of 1.5 times 10 to the minus 3 meters per second. And so we put it into our calculator just like that. 2.56 times 1.5 second e to the minus 3. And that gives us a volume flow rate of 0.00384 cubic meters per second. You can also put that in scientific notation because that's kind of a big number. And so in that case, it would equal 3.84 times 10 to the minus 3rd cubic meters per second. Both are correct answers. Thanks, and let me know if you have any questions about example problem 1.